Back in May, the team flew this system on board a research flight to prove out its capability.
This is a video that we took in flight. Here we are, you can see the aircraft banking, and on the screen you see a single blob there, and that blob is a Bose-Einstein condensate being produced. In this particular video, we're alternating between taking our BEC and then just imaging that directly, and taking the BEC and doing the first round of splitting that you'd need to do for interferometry. Whether you split or whether you just look at the BEC, you drop the atoms, they free fall briefly, and you do what's called absorption imaging, which is very simple. It's looking at the shadow the atoms create. And by looking at the relative density of these three blobs, you know the relative proportion of atoms in each of the three superposition states, and then you can back calculate what phase you would have accumulated, obviously due to an acceleration or rotation. The fact that you can even brag split a BEC in a plane and it's stable is remarkable. It's really, really amazing. And you can do so while the aircraft's moving around because the cloud moving in the background.
To add some context as to why this is so impressive, the enemy of all quantum engineering is noise, both mechanical and electromagnetic. It's what we are fighting when we're building a quantum computer that makes it so hard to get right, and what the team here is having to overcome.
You come from a physics lab where everything is bolted onto floating optical tables, and the magnetic and the light environment and everything else is quite well shielded, to taking this on a really dynamically challenging environment like an aircraft, where the aircraft is shaking violently because of the engines. There is a 6 gigahertz weather radar at the front of the thing blasting. There's air traffic control. It's a very challenging environment.
We are finally getting to the point where quantum is becoming robust. The learnings that are here will map directly to other quantum technologies and open up applications that we never thought possible.
The challenge now is to show the performance and the capabilities of the quantum sensors in more of the deployed trials, and benchmark that against existing technologies and try to rapidly ascend that technology development curve. So lots of the existing technologies I mentioned before are plateauing in their performance. We're not going to get a 10x or 100x improvement in fiber optic gyros or ring laser gyros in the next few years. They've been very well engineered by lots of very smart people, but they're coming to the end of their development trajectory. We're just at the start of the development trajectory for quantum technologies.
The first generation of our products will be something that's rack-mounted system, something that can go into a data center or onto a ship or an aircraft. But ultimately where we're going longer term, and when I say longer term, this is really over the next few years, is to ruggedize and miniaturize these systems using, for example, photonic integrated circuits. So taking the lasers and the optics and the vapor cells that you've seen and printing these on silicon, so that ultimately these products will be something that could fit in the palm of your hand.
But positioning isn't the only problem that these systems could tackle.
So because the atoms are sensitive to acceleration, they are by the same exact principle sensitive to gravity. And so if we can measure gravity with exquisite precision, it enables us to, for example, understand where there are mineral deposits under the Earth. We can measure tunnels, we can measure geologic formations.
One day it may have applications from helping guide autonomous vehicles around high-rise cities or helping us to navigate space. But first, it will be set to work to protect flights around the world, which as of 2024, 900 flights a day on average are now encountering GPS spoofing, a technology made possible by some of the most complicated but fundamental laws of our universe. Diving into these sorts of technologies is literally the coolest thing about what it is that I get to do as a factor of being on YouTube. If you like this video, I'm going to leave